Hello, here is a quick video on some of the questions on the trigonometry page of the summer work. Now, before I get started on that, there was one question on this page of the summer work here, beginning on limits. Now, I found the problem in your work, and right here, you didn't remember parentheses around the negative 3.5. So the calculator is not smart enough to know that your input is negative 3.5. So what your calculator is doing is squaring 3.5 and then making the answer negative. I did it on so you got negative 0.645. I did it on my calculator, and if it lets me show right here, maybe it won't. I put negative 3.5 in parentheses here, and then I actually get the right answer of 12. So if you redo that, remembering parentheses around every single input, then you're actually going to get y values that seem to approach infinity or approach negative infinity from either side of the vertical asymptote of -3. And then at -1, you can see how they seem to be approaching -0.5. So that was the issue there, and why your y values didn't seem to be doing the right thing. Now, I'm going to do a couple examples of this problem. I'm not going to do the same exact problem because I want to make sure you can do it on your own, but I am going to do some really similar to it so that we can review reference triangles, how you label them, and how you get the other trig functions. Now, what you have to remember is a reference triangle is just a triangle that's in the correct quadrant. There's quadrant 1, 2, 3. Oh, that's not 3. Hold on. Whoa. 3 and 4. Another thing you have to remember is the acronym All Students Take Calc. And what that tells you is A means that all the trig functions are positive in quadrant 1, which makes sense because to get to a point in quadrant 1, your x is positive and your y is quadrant. S means that sine and its reciprocal cosecant are positive, which makes sense because the x is negative but the y is positive. T means that tangent and its reciprocal cotangent are positive, which makes sense because the x is negative and the y is negative, but tangent, remember, is y over x. So if you have a negative over a negative, tangent will be positive. And C means that cosine and its reciprocal secant are positive in quadrant 4, which makes sense because to get to a point here, your x is positive and your y is negative. So I guess we should make sure we're clear that sine is y, cosine is x, tangent is y over x, and then cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So we have sine and cosecant, cosine and secant, tangent and cotangent. So you will need to know that. All right, so I'm gonna do an example that's really similar. So let me scroll down here. Just ignore that unit circle for a minute. That's for another question you had. So let's say that I'm given that the sine of theta is 4 over the square root of 17. And then I'm also given that cosine is less than 0, so cosine is negative. Notice that sine is positive. So you always start by drawing your coordinate plane and by deciding the quadrant. Don't do anything until you figure out what quadrant you're in, because if your reference triangle is drawn wrong, you're going to get the problem wrong. So now I need to think, okay, all students take calc. Sine is positive. So that means I could be here or here, where all of them are positive. I cannot be here or here. Now I know that cosine is negative. Well, in quadrant 1, all the trig functions are positive, so that definitely can't be it. And in quadrant 2, only sine is positive, and cosine, which is x, is negative. So I am in quadrant 2. So just draw yourself a triangle. Don't even worry about the scale of it. We don't care if it's accurately drawn, just a triangle. Here's your point. This, recall, is called the terminal side. And remember that whenever you draw an angle in trigonometry, trigonometry is all about triangles and creating triangles. If I were to draw the actual angle created by connecting this point to the origin, I would have an angle bigger than 90 degrees, and you can't make a triangle a right triangle with an angle bigger than 90 degrees. So then we make a reference angle, which the pre-calc book called theta prime, and the reference angle is from the terminal side straight down to the x-axis. Some people accidentally will make a reference triangle like this, where they connect the the terminal side to the y-axis, and that's just wrong. You have to be touching the x-axis. All right, so we have our reference triangle and we have our reference angle. Now we need to label the size. So I know that sine, let's make sure we will review this. So katoa, I prefer writing it as so ka toa. All right, so sine is opposite over hypotenuse, opposite over hypotenuse. Now I've already established that this is my angle right here. Here's my right angle. Now opposite is 4, so here's my opposite. Hypotenuse is root 17. Woo. Okay, so now I definitely need my adjacent side. So let's go ahead and get the adjacent side. 1 second. All right, so I pause it just so you didn't have to go through the Pythagorean theorem work because that's pretty quick. A squared plus b squared is c squared. I found that b is the square root of 1, which is 1. So my adjacent side is 1. Now, you have to remember that the Pythagorean theorem doesn't know that you're doing this on an actual coordinate plane where signs matter, like S-I-G-N. The sign matters. And all you have to do is look at this triangle and realize that in order to get to this point, if you go left and then up, your y is positive, but your x is negative. You can't get here without a negative x, so you need to manually put a -1 in. And then you really just have to list out the rest of them. So cosine theta is adjacent over hypotenuse, so adjacent over hypotenuse. It really is better practice to rationalize this. I know I didn't give it to you in rationalized form, but we are going to fix that. So negative root 17 over root 17 times root 17 is 17. Then I have tangent of theta, opposite over adjacent. And then let's do the reciprocals. I have cosecant of theta. The reciprocal of sine is root 17 over 4. Then I have secant of theta. The reciprocal of this is negative root 17 over 1. And then I have cotangent theta, which is -1/4. If you were to fix sine, you'd multiply by root 17 over root 17. So 4 root 17 over 17. Okay, so I think I'm going to do one more quickly. If you realize that you don't really need it, then just skip through this example, but I will do one more in case you want to see one. Let's try, I'm giving you, what the heck? All right, I'm giving you that cosine of theta is negative root 5 over 3. I'm giving you that cotangent of theta is positive. And this time, I don't want to list all 6, just for the sake of time. Let's just find secant of theta and cosecant of theta. All right, first step, figure out the quadrant you're in. All students take calc. Cosine is negative. Cotangent is positive. Now, okay, what is cotangent again? Cotangent is the reciprocal of tangent. So if cotangent is positive, that means tangent is positive. So I'm going to start with tangent first. So let's see, where is tangent positive? Tangent is positive in quadrant 1, where all of them are positive, and in quadrant 3, T stands for tangent. I can't be in 2 or 4. Now I need cosine to be negative. It can't be in quadrant 1 because all of them are positive. And also, to get to a point here, your x needs to be negative in order to even think about getting to that point. Okay, cool. So I'm just going to put a point there, and I'm going to draw a triangle. Here's my here's my terminal side. And you're connecting to the x-axis, not the y-axis. So here is my right angle by dropping to the x-axis. my actual angle from the initial side to the terminal side is way more than 90 degrees. So I'm going to use my reference angle, which is from the terminal side just to the x-axis, theta prime. That doesn't really matter that much, but just so you're aware of what technically it should be. Okay, cosine is, so ka toa, right here, adjacent over hypotenuse. And hold on. Okay, now I need to actually label my triangle here. So adjacent is, oh, okay, this is really important here. I have adjacent over hypotenuse. The question you asked is, where do I put the negative? Because technically, negative root 5 over 3 is the same as root 5 over negative 3, which is the same as an overall negative root 5 over 3. So you have to be really careful that you put the negative in the right spot. Let's just do adjacent over hypotenuse and see that, okay, which one's definitely negative. In order to go left, that has to be a negative x value. One thing to remember is the hypotenuse is never negative. Only the adjacent or the opposite could be negative, like the x or the y. Those are the only ones that can be negative. It's never the hypotenuse. All right, so we need to find this right here. I'm going to pause to get that work done quick. Is this recording? Yeah, okay, sorry. I found B. B is 2. So I'm going to put 2 right here. And I need secant and I need cosecant. All right, secant and cosecant are the ones that people aren't most comfortable with. They like SOHCAHTOA, they don't like the reciprocals as much. Secant, remember, is the reciprocal of cosine, and cosecant is the reciprocal of sine. Now, cosine is, well, I have cosine right here. That's nice. So it's just a reciprocal of that. I'm not even going to look at the triangle. So I have 3 over root 5. It's negative, which is negative 3 root 5 over 5. Now, cosecant is the reciprocal of sine. Sine would normally be opposite over hypotenuse, so cosecant will be hypotenuse over opposite. So hypotenuse over opposite, the opposite of my angle. 3 over 2. And I do need a negative 2 here. Oh my gosh. Remember how I just said you have to manually put in signs sometimes? The Pythagorean theorem didn't know that my 2 is actually negative. So you need that 2 here. And that means that cosecant is opposite over hypotenuse, so 3 over negative 2, negative 3 halves. All right, now in terms of the other question, hopefully that helps you do this one right here. In terms of, let me just say, the double angle identities, those don't really need to be memorized. There's only one question I've seen where those have to be used. I just wanted you to see them again and realize they exist. They're rarely seen on the AP exam, but they might come up twice during the year. In terms of solving the trig equations, really just pretend that the trig function is an x, like 4x squared minus 3 equals 0, 4x squared equals 3, x squared equals 3/4, x equals the square root of 3 over 2, because the square root of 4 is 2. And then really what you should have done is kept sine in it the whole time. So I have sine of theta is root 3 over 2. So in order to solve that, that's kind of the same as these questions right here. Now I did notice you are using degrees, and degrees are never used in AP Calc, ever, 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 ever. So don't ever write a degree again. You only use radians. Radians are your best friend. So we're from 0 to 2 pi, and we're going to use our wonderful unit circle here to answer these questions. Now, hopefully this is memorized. You know it like the back of your hand, but if it's not, then you are going to make sure it's memorized this year. So let me pick a couple here. Like if I know secant of theta is negative 2, so I have to evaluate this from 0 to 2 pi. I want to know what is theta. So that secant is negative 2. Now, I personally find it hard to think in terms of the reciprocals. So like cosecant, secant, cotangent. I prefer saying, all right, secant is the reciprocal of cosine. So if secant is negative 2, I know cosine is negative half. So now I want to think, okay, where in the unit circle is cosine negative half? Now, ideally, you would just visualize this in your head, but just, again, in case You're not there yet. Cosine is x. So I want to know, when is x negative half? And I can see that happens here and here. So at this angle, which is 2 pi over 3, and at this angle, which is 4 pi over 3. You are not going to say 120 degrees and 240 degrees. You're going to say 2 pi over 3 and 4 pi over 3. Now, what if it's written like this? Cosine inverse of negative 3 halves. That's the same exact thing as here. So let's take a look at this one here. Sine to see why they're the same. This is something that people do struggle with. If I want to get theta alone, because this is an equation, there's an equal sign. I'm solving. There's not an x here. The unknown is theta. To solve for theta, I need to get rid of sine. The function that undoes sine is its inverse, sine inverse. Sine inverse of sine cancels. I'm left with theta equals sine inverse of root 2 over 2. Now it looks just like this one and this one and this one. So these are really all asking the same thing. So let's answer that one. Sine inverse of root 2 over 2. I'm looking for the angle where the y value, sine, is root 2 over 2. Here I am given part of the ordered pair, and I'm looking for the angle. So where is y root 2 over 2? That happens here and here. So pi over 4, 3 pi over 4. It doesn't matter if they ask it with the inverse or if they ask it as a little equation. You're looking for theta either way. Theta equals that, equals whatever. So just for the sake of making sure this is answered right, sine inverse of a half. I know that my y value is half. Where on the unit circle, what angle rotation gives me sine is a half. So I have a y value of a half, a y value of half. That would be pi over 6 and 5 pi over 6. So that's how you would answer this one, pi over 6, 5 pi over 6. The ones that are different, we should probably just make sure we're okay here. A through G are all the same kind of question. What about H, I, and J? Here I have sine of negative 9 pi over 4. Notice I'm given a radian angle. I don't want an angle. Like in these questions, I supplied the angle. Here, I'm given the angle. I want to know part of an ordered pair. Okay, so that's the difference between these questions. So negative 9 pi over 4. The denominator means I split pi up into 4 pieces. So 1, 2, 3, 4, and then 1, 2, 3, 4. The negative means I rotate clockwise. Normally you rotate counterclockwise. So I have negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is my triangle. Negative 9 pi over 4 is the same as this angle on the unit circle, which is, ta-da, 7 pi over 4. And what did I want on that one? Was it sine? Yeah, sine of that. That's the y value, negative root 2 over 2. So I'm giving part of an ordered pair. Okay, so hopefully that helps answer those questions. Any more questions, feel free to email me.